today we're going to talk about inverse functions. And you've used these before with sine, cosine, and tangent. You've done it in geometry. We know you've done it in geometry. We're doing it in our geometry class right now. And so it's going to be reviewing some, but we use a little different terminology. I guess I didn't realize I had this written down here. That's the same thing, shortened version I already had you copied. The inverse of a trig function is used to find the angle when you know the trig ratio. The term that we're using that's different is arc sine, arc cosine, arc tangent. It means the inverse. Means the inverse of the sine, the inverse of the cosine, the inverse of the tangent. Okay? Can't do anything about the lines. Just sun coming between the shades. So these are called inverse relations. We don't call them inverse functions. So as I said yesterday, you're sometimes asked to solve a triangle. It means to find all the angle measures and side lengths when you're usually given two facts. So you take those two facts and you'll solve the rest of the triangle. Okay. Example. I'm sure that you could take your calculator and get a decimal value of this. But if they say find the exact value, that doesn't mean to the 10th decimal place or 12th, whatever your calculator shows. It means find the exact value. And so the method I'm going to show you to solve this problem is for you to understand how to get the exact value. All right? So arc cosine, again, is the same as saying the inverse cosine of some angle, we'll call it y. Oops, there. Of 4/5. I'm sorry, I messed this up. Is equal to y. And so what this is really saying is the cosine of y is equal to 4/5. Okay? The cosine of y is equal to 4/5. And so if I drew this right triangle, cosine means what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. And so if this is y, this is my adjacent side, and this is my hypotenuse. Adjacent is 4, hypotenuse is 5. How do I find that missing side? What are you saying it is? Good, because you recognize it's a what? A 3, 4, 5 right triangle, right? But if you did not know, if it wasn't a 4 and a 5, and you didn't know it to be a 3, 4, 5 triangle, how would I find that third side? Pythagorean theorem. I would say, we'll just call it A. A squared plus 4 squared equals 5 squared. Or we can cut right to the chase and say A squared equals 5 squared minus 4 squared. A is equal to the square root of that, and we get 3 either way. Okay? Okay, sorry, I thought you had a question. So what we're saying then is sine of this number is going to equal x. Okay? So what we did, we haven't found this number yet, have we? I mean, we could use our calculator and get a decimal value, but it's not going to be exact. So we haven't found this number yet. Okay? And that number is this y value. Alright? But we can go back and say sine of whatever that angle is, which is here, is going to equal what? What do we find A to be? 3. And so sine of y is going to equal opposite over, what's the rule for sine?
Opposite over hypotenuse.
And hypotenuse is 5. And so the sine of y is equal to x. And x is what we're looking for. So the sine of this number is equal to 3 over 5. Okay? Now, in this situation, 3 over 5 is a terminating decimal, 0.6, right? If you plug that in your calculator, work it out, you're probably going to get 0.6 unless you make a mistake. But not all of our triangles are going to be 3, 4, 5, and we're not going to all get nice numbers like that. Sometimes we work this out, we're going to have the 3 times square root of 7, or something strange like that. Okay? Square root of 36, or that's nice, sorry. Whoa. Square root of 37, okay? Something that's not a nice number, okay? And so the idea is use this information to draw your triangle and solve for that other side. Once you've solved for that other side, you're going to say sine of that angle is equal to what number? Then we use that ratio. Opposite over hypotenuse. Okay? What would the tangent, if this said tangent here, what would the tangent of this be?
3/4.
Opposite over adjacent, 3 over 4. Okay? If I ask for cosecant, cosecant's the reciprocal of sine, so it's hypotenuse over opposite. So it'd be 5 over 3. So you see what I'm saying? I could put any trig ratio in there and ask you to find it. And you would take the information of that arc cosine of 4/5 to draw your triangle and fill in the rest of the information to answer the question, to find the exact value. Okay? To find the exact value. All right. In this situation, they're not asking you to find the exact value. They're saying, find the approximate value of A. And A is equal to what? How do I do it? How do I find the missing angle? What do I use to find the missing angle?
Trigonometric ratios.
Okay. Let's back up to our notes. What's the first thing we do? To find an angle, we use arc sines, or inverse sines, or arc cosines, or inverse cosines, or arc tangents, or inverse cotangents. Right? So to find the angle, we do the inverse function, or the inverse relation, sorry, which is the inverse of this number. And so the inverse sine of 3/4 is about free to use your calculator, make sure you all know how to use it. They have you thinking this is obvious and trust somebody else and then you get it wrong.
48.6.
48.6? Anybody disagree with that?
value
Well,
is 800
Old math books used to always have a table of trig values in the back. Okay? And so, in the back, there'd be a 4-place decimal number that would represent every angle between 0 and 180. Actually 90, 0, 90. Because then you would just,
the opposite of
yeah,
that.
you'd use quadrants 2, 3, and 4 would be the same number, just half the time it'd be a different signs.
Oh.
Okay? And so there are tables out there that you can use. But they're usually a 4 decimal number, if I remember right. It's been a long time since I've used a table. I didn't even look if this book has a table in the back. It probably does. But we all have calculators, so anybody not get this number on their calculator? I don't want you not knowing how to solve this. It's pretty basic. We want to solve this triangle. This is the last example. How do I solve that triangle? To find, good. I use the Pythagorean theorem to find C. So C is equal to the square root of, we cut straight to the chase. C equals the square root of, yeah, 21 squared minus 11 squared. No, it's hypotenuse minus a length.
320.
Okay? Square root of 320.
Yeah.
So C is equal to square root of 320. 320 is 16 times 20. 16 times 2 is 32, is
Yeah.
that right? And 20 is 4 times 5. So the 16 times 4 times 5. What's square root of 16?
4.
And square root of 4 is, and 2 times 4 is, so we get 8 times square root of 5. Okay. If I went too fast on that, make sure you say something so we slow it down. I don't want anybody lost. Okay? Now, if you don't feel comfortable trying to go straight to that step, that's okay. You can write a squared equals b squared plus c squared and plug in your numbers and solve. Okay? Yeah.
Wait, wouldn't C have to be the hypotenuse?
It isn't in this picture. The rule we normally use says a squared plus b squared equals c squared, but in that rule, c represents the hypotenuse. In this picture, the hypotenuse is a.
Okay,
So you have to adjust your rule to match this problem.
Yeah, that's what I'm thinking. So when, oh, it's minus. I was confused because I thought we were attempting to find C.
Oh, okay.
Without.
Yeah, it's the hypotenuse squared minus the length squared will give you the other length squared.
Alright.
And if you square root that, you get the number. So we know A is 21, B is 11, C is 8, square root of 5. Now we can use any one of them, can't we, Garrett, to find angle A. Which trig ratios could we use to find A?
We already have it.
Oh, I'm sorry, we know A, it's a right angle, thanks. So we could use any one of them to find B. So which one do we want to use? So sine. So sine of B equals 11 over 21. And so B is going to equal the inverse sine of 11 over 21. So B is about
31.6.
Now how can I find C?
You can make C's complementary to B.
There you go. C and B have to be complementary. And so we're already rounding, right? And so for our answer to make sense here, we probably should have those two numbers add up to 90. And so it makes more sense to me to say that C, angle C, is equal to 90 minus 31.6 than it does to use my trig ratios, even though it might be more accurate the other way. I think it would look silly to have 31.6 and 58.5. Okay? Because then they don't really add up to 90 anymore, do they? So what should this be? 58.4. So we really only had to use our trig ratio once, didn't we? And if they give me the angle, they give me a second angle instead of two sides, okay? Then I can use that angle to find the other angle using this concept right here. And they'd have to give me one side, so I'd use that angle on one side to find another leg, okay? And then Pythagorean theorem I could use for the third one, or I could use the other trig ratio. All right? So tomorrow, you're going to work on this assignment. And here it is. That's going to be 5 to 35 odds, of course. I keep writing odd, but at some point I might quit writing that. If it's a book assignment, it's always going to be odds. That's what we're doing tomorrow. Today